Okay, we're going to be talking here about find about factoring the greatest common factor. And first of all, it's important to know what your greatest common factor is. So, greatest common factor, I know a lot of folks are going to focus first on this greatest, and this is important, but in a lot of ways, common and factor, what we're going to be doing is we're going to literally be looking to at a polynomial, and we're looking for the things that are common to all of them, and we'll divide all of them. So let's start with something fairly straightforward. I'm going to start with like 8x to the fourth minus 6x to the third. Now, when I'm finding the greatest common factor, I am doing a couple things. I'm looking for the common factors of all of the coefficients. And I can divide both of these things by 2. And it's probably a good idea to ask, is there anything bigger that will go into these? I can divide this by 2. I can't divide them by, I can't divide, I could divide this by 3. I can't divide this by 3. I could divide this by 4, but I couldn't divide this by 4. So literally, my greatest common factor for my coefficients is going to be a 2. The next thing that we're going to do is we're going to look for the common variables. And here I have an x in both of my terms. So I know I'm going to be taking an x out. And with this, I'm always going to take the lowest power that's here. So I notice that both of these things, I've got an x to the fourth and x to the third power. So I'm going to take out an x to the third. And when I do this, when I factor this out, this right here this is called our greatest common factor, but we haven't factored it yet. What we're going to do then is we're essentially dividing both of these terms by this. So 8 divided by 2 is 4. X to the fourth divided by x cubed is just an x. 6 divided by 2 is 3. X cubed divided by x cubed is 1. Now, with this, what I usually tell folks to do, this is literally what we're doing. We're literally saying, okay, this is 8x to the fourth over 2x cubed minus this, 6x cubed over our 2x cubed. And that is what is going to be inside this set of parentheses. But there's a lot of shortcuts. Usually I start with the coefficients, and then I'll say, oh, well, let's just subtract this power, the power of my greatest common factor, from what I have here. So 4 minus 3 is 1, 3 minus 3 is 0, so anything to the 0th power is a 1. But this is the underpinnings of this. Let's do another example. So let's say I've got, I'm going to do 12 m cubed n squared minus 14 m squared n cubed, and then plus 2 m squared n squared. And here I see I've got 12, 14, and 2, and it looks like 2 is the biggest number that will go into all of those. I have m's on all of them, and I've got n's on all of them. My lowest power on the m is a 2. My lowest power on the n is a 2. Now, when I do this, like I say, I'll show you what I do. I first start with the coefficients. 12 divided by 2 is 6. See, this is a minus, so I'm going to put a minus here. 14 divided by 2 is 7. And 2 divided by 2 is 1. I'm going to put this 1 here as a placeholder. We don't technically have to have it. Oh, actually, yes, we will. What am I thinking? Now at this point, I start looking at my variables. I say, oh, n squared divided by n squared is just 1, but m cubed, I'm just subtracting this power from this one, so I've just got a 6m there. On this term, m squared on both, which means I don't need to put an m here, but I am going to need another power of n here. And I've got m squared and n squared here, which means I've taken both of them out. So we're done right here. And remember, it's a good idea to sort of mentally check. And if you're check by multiplying 2m squared n squared times 6m, 2 times 6 is 12, m squared times m is m cubed, and we'll still have that n squared there. 2 times 7 is 14. I have my m squared, n squared times n is going to be n cubed, and 1 times something is itself, so we just have that term right there. So there we have, this is our quick review of factoring by, or actually greatest common factor.